I want to discuss the ability to build a truly cancelable HTTP request system. And there's a lot of misconception, especially at the client side, that when you abort a signal, when you send an abort signal, when you close the connection, that the request that is being processed on the back end is actually terminated, which is not entirely correct. So I want to shed some light on what is happening and why canceling an HTTP request, and specifically, is extremely difficult to implement. I understand that languages such as Golang have provided the hooks necessary at both the server side and the client side to achieve that. But even that, understanding that, you have to have the entire stack written in Go to build, to actually have this cancelable request actually successful. So this is the title of the Backend Engineering Show of this episode. How about we jump into it? Welcome to the Backend Engineering Show with your host Hussein Nasser. And yeah, HTTP request can't be just canceled, guys. Especially that we are in a stateless environment. And I'm going to talk about why it is very hard to cancel an HTTP request. And some of you might say, Hussein, I've canceled many requests. Of course. Well, to you at the client side or the front end, you think that the request has been canceled, but to us, the back end, it's very hard to propagate that cancellation signal all the way to the process that is being processing that actual request. So let's go back before the HTTP days and to the beautiful design of a client-server desktop app, right? Before even that, before going to the database, I have a local application, and I called a function, and that function is taking a long time to process my call. And let's say it's not talking to another external system, because that just complicates things. It is doing a process that is localized. How do you actually cancel that request, right? You're a programmer. You might have built something like that. You might add a parameter such as an abort signal, and you have a hook, a pointer to that, and you set a parameter to true, assuming you are in an asynchronous environment. And in the function, once you have to listen to that cancel event or that cancel bit. Once it's set, you just return immediately, right? We have built applications like that. So that's just one implementation. There might be better ways. There might be better like events and stuff like that. You can do something like that. However, if we move to a client-server architecture, and let's take a database, for example. And if I'm a client and I want to execute a SQL query, that's a request in itself, right? First, I have to establish a connection to the database. And that database connection is the channel by which I use to send SQL statements to the other end, which is the database. And the database will start executing and processing MySQL. No pun intended. MySQL, right? And the SQL at the back end start processing, and let's say it's taking sweet ass time to process that query. How do you actually cancel? You don't have any control about the database. You can't build this cancellation signaling, right? So either the database API and drivers at the client side can provide you with this mechanism, which most do, right? Or one implementation might be, hey, I'm just gonna close the connection. That's kind of the sludgehammer approach. Hey, close the connection. Closing the connection will basically terminate the connection, the bridge between the client and the server. But listen, even that is not enough to tell the database that, hey, cancel that request, because someone who built that database have to still listen and ping the socket, because this is not a single threaded thing, guys. Remember, databases are multi-threaded, right? Multi-processes. So the request that processed your socket, right? The process that processed your request, the socket, is different than the process that is executing your query. It's not the same one. We're not building Node.js here where everything is a main loop, right? Where some of the stuff are asynchronous and multi-threaded, but the other thread, the other process is executing the query. So how do the database communicate with each other? It says, okay, check, is the socket dead? Is the socket dead? Is the socket dead? You have to have this communication. And just recently, Postgres 14, we're talking Postgres 14, May 2021, they just implemented that feature. Imagine, in certain situation, when the client dies, the client dead. Why am I executing the query? Let's kill it. So just a simple client server cancellation, right? Which is just like your client and a server. And even that, we're having a hard time to implement cancellation correctly, right? Again, some databases may be doing it in a better way, different way, but this is what I'm talking about here. So if we just taking that sludgehammer approach, close the connection means cancel my request. But some implementation, you still have to implement it. Now imagine you're building that server, right? And that server is an HTTP server. And now you sent a request, an HTTP request. And this, now we're dealing with stateless stuff. That means we can be behind load balancers, we can be behind reverse proxies, we can be behind API gateways. So your request that you just sent might have passed through 3 or 4 or 5 or 6 TCP connections to get to a server that is actually processing it. So now to close a TCP connection between the client and whatever the front end, the edge that you sent that request to, doesn't mean anything. Because what does it mean? If you close the connection between you and the API gateway, is the API gateway smart enough to propagate that request and link it to the next layer of load balancers to send that, oh, by the way, client on port source 700 actually closed the connection, so I might as well, hey, I sent that request. It has to remember, oh, I sent a request through this pipe, through this TCP connection to this load balancer, so hey, close this connection as well. No, we don't do that. We never close connections on the backend because, hey, this is a shared pool, right? It's a shared pool of connection. We're multiplexing on the backend, especially if you're using something like Envoy. We're heavily multiplexing on the backend. So you can't just close a connection, right? So now that sludgehammer approach of closing that connection is gone, right? You can't just close that connection. So now you have to implement some sort of a way to cancel a request, but requests are stateless, right? So if you essentially sent a request to cancel a request, you can implement something like that. It's not impossible, but it's extremely difficult. You can essentially build a semantic yourself to cancel a request, right? And we're going to come to Golang and how they handle this stuff in a minute. But what you can do is, assuming you own the whole thing, the client and the server, if you don't, just the whole thing is just moot. You can't do it. You just can't, right? Unless you are provided with cancellation API that allows you to cancel requests, right? But if you have a backend like a random API gateway backend that doesn't have the concept of cancellation, you just can't do it. You can't just close the connection and hope the request stops processing on the backend 7, 6, 8 hops down. No way. How do you implement it, right? So here's how you actually can do it. If you uniquely identify each request, and then you issue a request to cancel an existing running request, given the request ID, that will be treated as just another request. Now, if you do that, then that request will be eventually poured into the server. Let's say for simplicity, you're gonna happen to hit the same server, which is not guaranteed by any chance. If and only if that cancellation request, which carries your request ID that you want to cancel, happens to hit that same server that the request is running on, then yes, the server will say, oh, this request ID, blah, 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 along with, is in my same vicinity, is in the same server. So go ahead and cancel it. And then you have the same logic that we talked about in the beginning, where you have a cancellation event. But what if your request, since HTTP is stateless, is going to definitely hit another server? It's going to hit another server that has nothing to do with the service. I was like, what the hell is this request? I don't know anything about it. I'm not executing that. Then you might say, Hussein, that's not hard. We can build a database where we're storing the state of every request. All right? This request is being executed on this server. And then when you receive a request, a cancellation request, you can query this database. Okay, you see where I'm going with this, right? This is not easy. Imagine building something like that. You can't. You can't get it right. You cannot get it right. You cannot cancel HTTP requests. Stop saying you can. You can't. Just vanilla. See how complex this thing is. And then you might say, Hussein, well, I'm not going to use the backend database. What are you talking about? That's just complex. I'm going to set up my load balancers. And you can do something, absolutely, you can do that. Where I'm going to use an IP hash load balancing algorithm so that if my request IDs, if the request ID matches, it hashes, always goes to a certain server. You can definitely do that. And in that case, you can stick with a stateful solution where your cancellation request will go to the same server that the request is running on. And then at that state, the load balancer will make sure to forward the request to that server in order to actually cancel it locally. So it's still not easy, because at the load balancers now you have to configure this load balancer algorithm to be essentially what do we call this? The sticky session kind of a request, right? So if you built it this way, then you can implement it. So Golang have this concept of context, where you can cancel a request provide a context to the request. And I'm guessing that they sent some sort of a metadata uniquely identifying the request. That's just a guess. Golang developers out there, tell me if I'm wrong. So assuming you also built your server in Golang, only then you can take advantage of this cancellation. If your server is in somehow Node.js web server and your client is Golang, that's useless. You cannot cancel a request because HTTP has a concept of a cancellation, right? It just doesn't exist because it's a stateless. There's connections. There's no way you can guarantee you're hitting that server all the time. So if you built it this way with Golang, and you configured your load balancers to be sticky so that you're always hitting the same server, then yes, you might be able to cancel an HTTP request. So let's talk about gRPC. gRPC have the ability to cancel requests, and the reason is it's possible because it's a stateful protocol. gRPC allow you to do an end-to-end connection to a backend. So if I send a request, the request has a stream ID because it's using HTTP2. So it's we have a unique identifier to a request in some sort. So the request in HTTP2, specifically in gRPC, which uses HTTP2, is kind of identified with the stream ID. So there's a unique identifier. And it's stateful because especially if you're doing a bidirectional streams, so then it's bidirectional. And assuming you have proxies and reverse proxy and load balancers that support gRPC correctly at layer 7, or you have a dumb layer 4 reverse proxy which just blindly tether you to a backend, then the whole thing is almost one connection. It's not really one connection, but it is. All packets that are sent always goes through the same path. It will always go to certain connection and will be directed to a direct connection to the same connection all the time, because this is stateful. We cannot play with stateful layer 4 proxying. We always take you to the same. Only then I see that you can be able to cancel requests with gRPC. gRPC is perfect for this, right? Because we know the request ID, right? We are stateful all the way. We know that all the request goes through it's a single connection all the way, right? Yeah, it's not scalable because that connection at layer 4, which carries so many streams, so many requests, if it's funneled through the same socket, then it's not really scalable. That's why people implement gRPC at layer 7 so that they can multiplex streams, bidirectional streams at a lower level stream IDs, so that we can multiplex them through different connection. It doesn't matter, right? Otherwise we're stuck, right? Because this way, if I have a layer 7 gRPC terminator, then I can scale my backend, right? Instead of having all my requests go to a single server, they will go to multiple servers per stream. Obviously, any future request on the same stream will go to the same server, right? Again, we're going into details, but that's the idea. HTTP cancellation is extremely difficult to implement, right? Just closing the connection, hoping things will work. Well, if you have set up all of your backend to be layer 4, again, which doesn't scale as nicely as a layer 7 proxying or load balancing, then you might get away with cancellation. But again, it's very expensive. Just terminating the TCP connection, as we said in summary, terminating the TCP connection is a bad idea, because in HTTP, you might be multiplexing. On the backend, we never terminate connections just because your stinking request want to close the connection. We won't never terminate the connection on the backend. We're going to leave it because we want to reuse it, right? We want to reuse it for something else. But in a layer 4 configuration, we don't have a choice, right? So in a layer 4 configuration, we'll have to terminate that request and that TCP connection, which is a lot of work, a lot of setup cost to tear down the connection and then turn around and start back a new connection. Even though if we terminate the connection, we cannot guarantee that the actual final backend will listen to the event that the socket has been closed and then terminate the request on the backend. Very, very difficult, right? So yeah, in summary, HTTP cancellation is possible, but it's very hard to implement, and implement correctly, might I say, right? In a real production environment, right? All right, guys, that's what I wanted to talk about. Let me know if you have any other thoughts. What did I miss? And tell me more about how Golang, and I have the book. Actually, the camera is standing behind a book called Network Programming with Go. Beautiful, beautiful book that explains that. I'm reading more details about that. But as I read, I have questions and I answer them myself. You know, that's how you understand. That's how you know you actually understand what's going on, right? You don't wait for the book to tell you. You actually just know what the book is gonna say before you read it. Does that make sense? Because there is basic principles at the end of the day, and you cannot diverge from these basic principles. Once you understand that, you can just piece everything down. The answers lie squarely within the question all the time. There is no question in earth when it comes to software engineering that is not essentially its answer is within it. Once you really understand what's the fluff behind it, right? What's the fundamentals behind it? It's almost like always like that. If you cannot answer, that means you just don't understand the basic principles behind it. Does that make sense? That was like a little bit deep. All right, guys, that's it for me today. I'm gonna see you in the next one. You guys stay awesome. Goodbye.